Hi, in this video, I'm going to demonstrate to you on how to carry out the gearbox experiment to collect the data required from the experiment. Well, you can see this is the gearbox apparatus we're going to use for this gearbox experiment. It mainly consists of a motor, which is in this box here. And this is the gearbox, and the gear ratio between the motor and the gearbox is 1:7. And the control system for the apparatus is here. So this is the on-off switch, on indicator, and this is a motor RPM indicator times 100 revolution per minute. And this is the motor torque in a unit of times 10 Newton millimeter. So in this experiment, so motor is the input and gearbox shaft is the output. So in order to measure the input RPM, which is the motor RPM, so we can use this indicator. As for the input torque of the motor, we use this indicator. As for the output torque to be measured, we use a setup like this, which is called a pony brake setup. So with this setup, so we have two pulleys and a scale here, and we're going to load this hanger on this side with a mass, and we take the difference between the force on this side to that side, and we times it with the radius will actually give us the torque at the output or at the pulley of the gearbox. So there are two parts for this experiment. So in part A, so we're going to maintain the mass constant, but we're going to increase the speed of the motor from 6 to 18, which is 600 RPM to 1,800 RPM. Of course, before we start doing the experiment, so on the power supply, make sure that the gearbox is in good working condition. So I already on the gearbox, and I can use this knob to increase the speed of the motor to make sure that the gearbox is working properly. So now I maintain the RPM of the motor at 600 RPM. And I'm going to add mass to the hanger. So I'm going to add it with 50 gram, followed by 100 gram. So the hanger itself is of a weight of 50 gram. So now I have 100 gram on the weight hanger. So I add on with 100 gram. So now I have 200 gram. So add on with another 100 gram. So now I have 300 gram on the hanger. So I record down what is the reading of the scale. I record down what is the torque of the motor using this indicator. So this will be the first reading for our experiment. And then I'm going to increase the speed now from 600. So I'm going to increase it to 900 RPM. So this is now at 900 RPM. So at 900 RPM, so I read the scale reading, I read the scale reading, and I jot down these two readings. And then I increase again the motor speed to 1200 RPM. So at 1200 RPM, so I record down what is the reading of this scale and also what is the reading of this indicator. I increase it further, right, from 1002. Now I increase this to 1005. Record the scale reading, record the indicator reading, and then increase to the last RPM, which is 1008. Record the scale reading, record the indicator reading. When this is done, so I bring the speed of the motor now back to 0. So for the second part of the experiment, so I remove all the meshes on the hanger. And then I increase the speed of the motor to 1002 RPM. So at this RPM, without any mesh on the hanger, so I jot down the reading of the scale and also the reading of the torque shown by this indicator. So with the speed maintained at 1002 RPM, so I'm going to add a mass of 50 gram to the mesh hanger. So now I have a total of 100 gram of mass add on with the hanger mass. So I record down the reading of the scale. I record down a reading of the motor torque. So after that, I add 100 gram to the hanger. So now I have a total of 200 gram. Record down the scale and also the motor torque. Add another 50 gram of mass. So again, I record down the scale reading and the indicator reading. So add another 100 gram of mass. And I record down again the reading of the scale and also of the indicator. So when I'm done with this, so I bring the motor speed to 0 again, and I off the supply of the gearbox.